All right, y'all, we're going to talk about reinforcement learning for reliable agents today. So it's an open secret, I think, in the industry that, most AI agents just don't work, right? A lot of times we see these fancy demos, they don't really hold up in production. Obviously, like this depends on, how much of agentic behavior we're talking about. If you have a simple agent versus like a multi-step, multi-tool, all the way out to autonomous, they sort of get worse and worse as you go out that spectrum. It's also clear that prompting isn't enough, at least for now. Maybe in the future it will be. If prompting was enough, we would have reliable agents today, but it's clearly not quite enough at the stage we're at. So the question we've been asking is, can reinforcement learning get us to reliable agents? And so a little bit of background on reinforcement learning with LLMs. Originally we had RLHF, which is reinforcement learning human feedback. This is the magic that actually gave us ChatGPT, right? So a lot of people, when they think of reinforcement learning with LLMs, they think about O1 or R1, these amazing reasoning models we have now. But reinforcement learning has actually been around for a long time, and we used it to bring about ChatGPT with something called InstructGPT, where we're basically just taking a base LLM and teaching it multi-turn conversations. And the most common algorithms here are, PPO and DPO. And sort of how you do this is the LLM would generate multiple responses. Then you have a reviewer just rank these responses. And then you have a reward model that's trained to mimic those user preferences. And then the reward model is used to train the LLM. And so the reward signal can come from a number of different things, right? So you can have a binary good, bad signal. You can have a ranked signal. So you take like, say, maybe 4 responses and you rank which ones, rank them in order of which ones you prefer. And then you could score them from like 0 to n. So it's really common to score maybe 0 to 4, and you just give them different rankings around that. And then you can also just have textual feedback, was really interesting. We've been playing around with this a lot recently, but sort of just modeling multi-turn conversations where the LLM both models the assistant and models the user. And I actually think this is a really promising path forward. And so what's the other type? Well, we have RLVR, right? And this is the magic that gave us O1 and R1. And the idea is we just have verifiable rewards instead of a reward model, right? The most common algorithm here is GRPO. And so what happens here is the LLM, again, generates multiple responses to any given prompt. But then those responses are deterministically verified, right? So if it's a math problem, there's only one right answer. There's not a bunch of right answers. It's just, it needs to output one right answer, right? So we can deterministically validate, if that answer is correct. And then a reward model is still trained to sort of mimic those user preferences. And then you can use that reward model to train an LLM. So why does RLVR work so well, right? So we had a lot of reinforcement learning back with ChatGPT, which are RLHF. And this obviously continued. I don't think a lot of people were really aware of it, but it continued to evolve. But then we had this massive liftoff with RLVR, and we saw O1 and R1 doing these amazing things. And so what's the magic behind RLVR? Well, it's just that it doesn't really have to deal with reward hacking. So here's an example right here of where OpenAI used the game score as a reward. But the agent just learned it could drive in a circle and it could just pick these power-ups, every time it goes across, and it would win the game. It would get the highest score. And so models do this all the time. Like if anyone's, spent time training models, you'll know like anytime they can cheat, they will cheat, right? Like they will take every opportunity they can get to cheat. And this just gets into gradient descent and how that works. But this is a real challenge, right? Because most problems aren't RLVR, right? So we have this thing RLVR that works amazingly, but it's really just like a very small part of the problems we'd want to use with LLMs. And so the bigger prize is actually figuring out, likely how we can defeat reward hacking in one form or another. So one of the things we've been asking is, can reasoning defeat reward hacking, right? And this is sort of GAN-like. So you would have, an agent trying to solve the puzzle, and then you'd have a validator that's also reasoning about it. Like, hey, was this actually a successful thing? And you sort of train them in tandem, right? The other thing we can maybe do here is just use less data, right? So right now, like a big reason why we need these reward models is that you have to train these agents on so much data, right? But we as humans just don't need that much data. We just need like a bit of feedback. We need a bit of direction. We can sort of piece the whole thing together. So there's been a lot of work recently to see, like, on learning on really minimal examples. Obviously, we have this a bit with, just prompt engineering, few shot learning, but actually getting into the training as well. And you could do this, potentially with like a lot of data augmentation and a lot of, LLM sort of generating augmented data to your given prompts. And so, yeah, the question is, will this work for agents, right? So if we're getting into like multi-turn tool calling agents, is this something that can RL help with that? And I think, we've seen already companies like Manus, like openly discuss that, like, making agents work is more of an alignment problem than anything, which is pretty good signal that they're seeing that internally. And, the intuition here is like, it's way easier for an LLM to verify an action was correct than it is to actually generate the correct action, right? So there's a way to kind of leapfrog up this, where you just train it on to like figure out if something was done right, which actually does pretty well. And then using that, we can get into the data flywheel, right? So in the data flywheel, we talked about this a little bit in the last talk here, but once you've approximated the human signal, right, you can replace that with an LLM, and then this gets known as RLAIF. So it's reinforcement learning AI feedback. And then the LM could just sit in that loop, and you could just generate tasks, maybe within a skill set. You just generate a bunch of tasks, and then you have the LLM actually become the verifier instead of the human. And this gives you basically infinite data, and you can just train away. Again, the challenge here is reward hacking. And yeah, I guess, question is how well does this work, right? So we've been working on this for a little while now, and it definitely does work, right? So you can pretty easily outperform most frontier models, particularly on complex tasks and tasks that are out of distribution for them. It's also cheap and fast and reliable, which is a nice add. People who have dealt a lot with frontier models probably know they have absolutely horrendous uptime. I actually have no idea how you like build something on a single frontier model. I guess that's why Light LLM and Portkey are so popular, is that, like, the uptime is just absolutely terrible. If you want any sort of production service, it actually becomes pretty challenging. So yeah, we have the ability to run these things, just locally, train up a model that's much smaller and faster that we can run on our own infrastructure, and can perform better. So I think this is, an exciting direction overall. And then, yeah, a question we've explored as well is, can we do interactive learning? Like, can we teach an agent really in real time, how to do a specific task? So we've created this little open source library called DarkRL. They can kind of see playing right now. And it does sort of the ChatGPT thing of like generating out dual responses. You sort of choose, you choose one of those responses, and then it actually learns in real time. So it actually does RL training like in real time as you click that button. It's immediately trained. We developed some kernels to improve the speed of both training and inference within a single model, which I think is really exciting. And yeah, we're asking the questions of like, what if every LLM was an online LLM? So what if every LLM where you had a generate method, you also had a learn method, and you could just send data to immediately. It's immediately updated, right? Yep, and that's it. So thanks. If y'all want to catch up, we have this library now. We're playing around with these ideas. It's called DarkRL. Yeah, come check it out. I'm always happy to chat with anybody that's around. So thank y'all.
Awesome. Thank you so much. Yeah, that was again, these lightning talks are always so dense. There's so much information like rip through. So love it. Totally. So folks, if you have like questions, feel free to drop them in the chat. We have another talk in like 5 minutes, so we have a little bit of time. But yeah, while we're kind of like here, is there a way people should connect with you? Should they just go to this GitHub if they have other questions and want to follow up?
Yeah, the GitHub's probably the best place to keep up.
Cool.
I'd say that's probably the easiest right now. Awesome. Yeah, feel free to follow the org or whatever. We're doing a lot of stuff in this space, and yeah, I mean, feel free to reach out from there. I think our GitHubs point you to like a Discord and a Slack and stuff. So feel free to jump in there if you want to chat. So.
Awesome, cool. And maybe one. I don't see any questions in the chat, so maybe just one from me. Getting to this point to where you have a reward function from like mimicking possibly like human taste more or less. How do you think about the balance between like quality and quantity there? Like, do you
it's really
spend a lot of time
challenging.
making high quality? How much data do you typically need? Like, what does it look like?
Yeah, so we found a couple of really interesting things here. Like one is we tried to train binary reward models, right? That just said yes, no to a task, because it was particularly easy to just like take, just have a user say thumbs up, thumbs down on a particular response, right? We actually had a lot of trouble training binary reward models. You really have to balance the data. They're super biased, So like if your data set, say, has 60% yeses and 40% nos, the model will just naturally go to 60%, without actually knowing what it's doing. It just gets biased, in that direction. And that becomes really hard with like online learning, right? So if you're offline, you can like always rebalance the data set. But if you're trying to do this stuff online, it becomes really, really challenging to do that. But yeah, we're always thinking of ways to sort of do this with less data. And yeah, it's challenging. So a lot of like data augmentation seems possible here. We have an intuition. We sort of found that for every like task an agent does, for every specific action within that task, there are numerous other tasks in which that action would be valid, right? So you can basically take like a task within an action and send it to an LLM and say like, what other tasks would this action be valid for? It turns out you can generate a lot of other tasks, and you could sort of like bootstrap up training easier that way with less data. So
awesome. Just check the chat real quick to see if there was another question that came in. I don't see anything. So I think with that, we'll say goodbye to Patrick Barker, who I assume has no relation to Travis Barker.
That's correct, unfortunately. Yeah.
I'm just trying to get into that Kardashian party,
Yeah. I'm a pretty bad drummer too, so.
Awesome. Take care. Thank you so much for coming.
Thank you. Cheers.